Okay, so I'm going to review the tutorial problem for Module 6. There are 5 problems. Let's begin with the matrix indexing. Okay, this question is talk about the logical matrix indexing. Let's copy this code and store TUT06 matrix index. Okay, what is the question A? Question A is create the variable matrix logical 1 which determine if element of mat 1 is greater than 2. Okay, mat 1 matrix logical 1 is the matrix 1 greater than 2. Okay. That's it. Okay, so if I show the corresponding slide is here's the relational operator between the matrix and scalar, right? These are the element-wise operation of this operator between each element and then scalar, right? Make sense? Okay. B is so mat logical 2, which determine if each element in mat 2 is greater than the first element in a vector 1. Okay? This one is a logical 2, mat 2 is greater than vector 1 first element, right? Okay. I think the logic is exactly same with the first one. And the difference is we can put this code to read the first element on the vector 1, right? C is the create a matrix logical 3 which determine each element of mat 3 is less than or equal to the element in the corresponding index of the matrix 4. So these are this syntax, this one, this one. Okay, so use the relation operator between the two matrices. Okay, in that case, they're do operation between the elements at the same location. Okay. This case, mat 3 is less than and equal to mat 4. Okay. This create variable is the same mat 3, 4. Okay. 3, 4, which determine the mat 2, mat 3, and mat 4 are identical. Okay, we can first start with the mat 2. Okay, the programming logic of this question is we first compare the element at the same location between the mat 2 and mat 3, and then mat 2 and mat 4. Okay. And then, if these elements are exactly same, identical, that means all the elements are 1, right? How to check that all elements are 1 or not? That's the all command. This one, all. Return true only if everything input is true. Okay, so let's do this. First, mat 2 and math 3 and math sorry, math 2 equal to math 3, right? Then and math 2 equal to math 4. Okay? So think about if math 2, math 3, and math 4 are identical. This one is to give us all the 1 matrix. This one give us all the 1 matrix. Okay? To check if these 2 matrices are 1, you can just simply use the AND. And then, so let's do this. This one is not the logical value, right? Logical D, and then is the same. Math 2, 3, 4. All math D like this, right? Does it make sense? So for instance, okay, so let's run this. Okay, math 2 is this one, right? So what about we can try on this one, math 2 is equal to math 2. That is all the 1 matrix, right? It's a logical matrix. Okay, so if we do math 2 go to math 2 and math 2 go to math 2, this gives us all the logical matrix. Math like this. What about this one? This one followed some kind of general direction of the built-in function. For instance, in this case, all and matrix, and then they do the operation in the vertical direction first. That's why there's a row vector. So to check if these all elements are 1, we can do this operation. Okay? Make sense? But do not write your solution like this. Okay? That's not the true answer. Do you know why? Math 2 equal to math. So in this syntax, they run the syntax from left and right. They first execute this script. What is this script is? This one is, I'm just saying that I'm just assume the situation that math 2, math 3, and math 4 are the same. That's why I just put the math 2, math 2, math 2 here, right? And then this one give us logical 1 matrix, right? Okay, output is a logical matrix, but logical 1 matrix is equal to math 2 numeric matrix. Of course, the numeric matrix there's a number, not the all the 1, right? Okay, and that's why this one's give us a false, or sometimes it's a 1. 1 means the location where math 2. Okay, so here math 2. See this? If there's a 1 here, note that's the previous result. This one is all the 1 matrix. That's why only this element is 1. So basically, I'm saying that this is not the answer. So do not write an answer like 3 math 4. Okay, this is not an answer. Okay. Okay, what about the problem E? E is the math 3, 3 and 10 to determine the math 3 greater than 3 and math 3 is less than 10. Okay. Right? And then the question, okay, so this one's not true. So math 3 e log e. Okay. So question is asking all if so determine all elements, right? All elements to check that all elements that satisfy this condition. Similar to the problem D, we are using 3, 3, 10 using all comment like this. Okay. Does it make sense? Okay. So one correction is this problem is not asking you about the logical matrix indexing. This one is let's just use the malloc operator. Okay. Okay, so let's run this problem. Okay, there is a error where, oh, this one is a log D, right? Run it, no error. Okay, copy this code, and then paste here. Run it. Error, submit. Okay, what is the incorrect answer? Mat log 2. Okay, is mat log 2. Okay, that is mat log 2. Mat log 2 which determined which mat 2 is greater than the first element in the vector 1. Mat 2 is a greater than, so it should be this one, right? So let's fix the solution. Okay. Okay, good. Next question is a built-in function and array operation. Okay. Store the tutorial 6 built-in function array operation. Okay. So you need to write a script that can create a variable names of value a that contain the number of a negative value in the mat 1. Okay. Let me first copy this code. Okay. Then A is the count a negative value. Okay. I first check if where is the negative value. So mat 1 is less than 1. Okay, less than 0. And then if it is a negative value, that's the true, right? Otherwise, it's a false, right? Understand that? For instance, let's do this with this example. Okay. Sorry. Mat 1 is the 1, 3 minus 1. 2 minus 2, 1 minus 3. Okay. Okay. So let me copy this. Clear. Okay. Okay. If I do this operation, it gives us this vector. Why? Only these two elements, -1, -3, are negative value. That's why this condition statement true, the other place is a 0. Okay? Then how to find out how to compute the number of negative value here? We can simply sum the all element, that is the 2, right? So you can mat A, mat log A is D, mat 1 is less than 0, and then value A become a sum, mat A all. Okay, does it make sense? Okay, you can write the script like this. Okay. Okay. So psi function support the matrix, right? If you put the matrix here, okay, and let's do here, sine mat 1, so give you the signs of your value. So if you do this -1 equal to -1 is to find out the -1 location. So it's basically same, right? Okay. And then do this operation, sum all element. This could be also written as mat sum, like this, right? Okay. B is contain the number of odd value. Okay. So mat log B. How to find out the odd value? We already learned about this one, right? Mat 2 is a 2. It's a ramp function. So if you see the ramp function support the array type, matrix, and then scalar. Okay. So this one, okay, let me do this. Mat 1, so this one, ram mat 1, 2, give you the remainder when you divide the 2 to each element. Okay, that's the remainder. Okay, what is the odd number? Odd number is D, not D, 0, right? So this example, mat 2 is the 1, 3, 2, 2, 6, 4, mat 2, ram, mat 2, 2. This one is equal to so 0, that is 2, right? Only 2. Okay, that's similar to this because there's a minus. But here mat 2 is only the positive value, right? So random I. So you can check the odd numbers like this, okay? Or you can check the number like this. But either one is fine, okay? But let's do this because we already know that mat 2 has only the positive integer, so more than 0, right? Then how can I get the number of value? That is the sum mat be like this. Okay. C is create the variable value C contain the number of multiple of the 3. How to check the multiple of the 3? Can still use the remainder. So not mat2. Oh, yeah, here mat2. So mat2 is a multiple. 2 is a 3. If it's a multiple, the remainder is the 0, right? So C, the remainder is a 0. Okay. D is a value, create the value D contain the sum of the 5 lowest value in mat2. Okay. To find out this lowest value, 5 lowest value in mat2, we can sort this matrix. Okay. When you're sorting this matrix, you should not do like this. You should not do like this. The default is ascending order, right? You should not do this one. Why? This one gives you the matrix. Sorted the matrix in the vertical direction. Okay? This is not the sorting the matrix in the lowest to the highest one. Okay? The default direction is a vertical. So we should to pick the lowest of 5 number, we should do like this. Okay? And then value D is the sum, sort them at 2, first the 5 elements, right? Summing up. Okay? So F E is the value E is the contain the average of the 4 highest value in mat3. Okay, so this one is the same thing. So mat3 sorting. Okay, so in this case we pick the highest value. So to solve this one is much easier. You can sorting your matrix in the descending order. And then value E is the average of the 4 highest values. Sort the mat3 4 highest value like this. Okay. And then the last question F is the maximum distance between the 2 value in vector 1. Okay. Maximum distance. So here, vector 1 is a 3m by 1, right? Vector 1 is a 3m by 1. That is. So, okay. The number of elements of the F is the numel vector 1. Then we can make the double loop structure like this, and then we set the value F is the 0. Okay, then we compare the distance between these 2 elements. Okay, how to find out the distance? We value vector 1 II minus vector 1 JJ and absolute. That's the distance, right? Okay, so F value F is the larger than this distance. This one is the logic that we learned, how to compute how to find out the maximum number, right? Value 2 is the distance. Okay. Does it make sense? Okay, let's run this script to here. Okay, vector 1 is this one. Okay, and then run it. Value f. This should be this one, right? The distance is larger than the value f, so that should be this one. And then run it. Then run. And vector 1 is this one. Value f is the 198. Okay. But there's a much easier way to do that. Okay. Option 1. What is the maximum distance between the two values? That is just the max minus mean. Okay. Okay. Right? It's a minimum, so max minus minimum is the maximum distance, right? So if you think more about this problems, you can write this as a script, but if you already learned these types of the nested loop structure, you can solve this problem using this nested loop. Okay? Then run it, no error, copy this, paste here, run it, no error, submit. Okay, good. Okay, the next problem is array operation with the built-in functions. Tutorial, array operation, built-in function. Okay. Okay, so let's copy this code. And A is there 39? The value is true if there exists element in the greater than or equal to 39 in matrix 1. Okay, so mat 1 is larger than, greater than, equal to 39. Logical matrix A. Right? Then how to find out that this element in the matrix or not? What built-in function do we use? Any, right? We need to use is there 39 is the any mat A. Okay, makes sense. But by the way, if you see the any, there's the syntax of this one, all. Okay, so we can also write a script like a any mat. This one is work. Okay. Okay, B is the mat 2 is a copy from the mat 1. And then all elements are larger than 10 in mat 2, so I replace it to the 20. Okay. Mat 1, mat 2 is a larger than 10. That is a logical matrix. We can use this logical matrix as logical indexing to referring those elements. like this. That is replace the 20. Okay, that is the topic of this one. Logical indexing. So if you see this, indexes are larger than 3 is A is larger than 3 is a scalar and matrix. The index larger than 3 matrix looks like this one, right? Directly use this matrix as logical indexing, and then you assign this a new value. Then you can change the value like this. Okay? Let's do this. Vector 3 is copied from the second row of the mat 1. Okay. All elements at all locations are replaced to 20 if they are larger than 10. Okay. The key is we are going to find out their index. Okay. For instance, here is something. So we are going to use this script, right? But key is how to find out this index vector. Okay. The condition 1 is, okay, first, the element is larger than 10, right? The other condition is the location are odd location. Let's make a short example. One, 2, 3, 100, 200, and 21. Okay. Where is the larger than the 10? That is this 4, right? Okay. Where is the odd location? That is this one, oh no. This one, this one, right? Okay. If you see this figure, okay, you're going to find out this problem is like a logical indexing problem. Okay, how? Okay, we first generate the logical vector 1. The vector 1 is larger than 10. Okay, then what is the value? 0, 0, 0, 1, 1, 1, 1, right? So yellow. Okay, yellow. Okay, and logical D2 is the logical 0, 1 by 1, 2, 3, 4, 7. Okay, this one is a logical 0. No. This one is a logical 0 vector, right? Then, logic 2, you're accessing the odd number location and assign true. Then, okay, so let's move the okay, and then you will see log 2 become a 1, 0, 1, 0, 1, 0, 1. Okay, what is this one? Magenta. Okay, makes sense. Okay, so here Our goals again is vector 1 something 20, right? This should be the logical index vector to assign this 20. Okay, where we are going to assign this 20, that is here and here, right? Okay, in this case, how to find out the logical matrix? In the end, our goal is to 0, 0, 0, 0, 1, 0, 1, right? That's our goal. Okay, so to compute this one, the final logical vector, final is the logical 1 and logical 2. That is, comma, this one, right? Okay, then we can write the like this. Okay, makes sense. A little bit tricky, but you can solve the based on the material in the module 6, right? Okay, so let's do this. Log 1 is a vector 1. Okay, let me first define the vector 3 is a copied from the second row, right? And then log 1 is the vector 3 is larger than 10. Log 2 vector logical okay. So the reason there's a flag is I mean there's a way to define that it's a logical matrix like this one, like this. Okay, if you see that here, type name, so you can define that these are specific types of the matrix, and this one is all false. 1 by 7, y7, so not 7, sorry, this should be n, right? This case n. Okay, and then logical final matrix is logical 1 and logical 2. Make sense? Okay, let me run this code first. No error. Okay, so clear. Run it. Vector 3 is this one. Log 1. More than 10, more than 10, more than 10, less than 10. That's why it's a 0, right? Log 2 is the... Oh, sorry. I didn't assign the true matrix, right? 1, 2, 2, and, right? So true, right? Okay, run it again. And then logical 2 is the all the 1 at the odd location. Okay, logic 1 is this one. So if we do this AND operator, you can pick up the odd location where is the number is more than 10. Okay, so finally vector 3 is local final, it's become 20. Okay, does it make sense? Okay, the another way to solve this problem is, oh, by the way, if you solved this problem using the loop statement, that's fine. You're able to develop your own logic to solve this problem using the loop. That's good. Okay. Another way is let's assign the vector 1, the vector 3. Okay. Then we are condition statement. Vector 3 is larger than 10. Okay. Right. So condition 10 is the 1 by n vector, right? 1 by n vector. Our goal is to assign the value at the odd location. This means we just delete the all value in the even location. Okay. Even location is set to 0. Okay. Then we can simply condition 10. So okay. Do you understand this logic? Okay. Let me run this. Vector 3, this one, right? Condition 10. Okay. So this is not a good example. Okay. Run it again. 10 is this one. So our goal is to only the turning off the odd location, right? How? We can just simply assign the even location to the false. I'll say false. Okay, 0 or false are same. Okay. And then, okay, let's do this. Run condition 10. This one. Run, execute this line. Then condition 10 become like this. Set the 0 or the even location. Then we can use this logical vector as a indexing of the vector 3. Okay. Make sense? Okay. All right. Oh. Okay, what about the D? D is the maximum pair contain the maximum sum of a pair. Let's assume that we are adding the two numbers in the vector 1 in turn without overlap. Let me first see this example. Vector 1 is the 1, 2, 4, 5, 4, 2, right? So we are going to add a two value in order in turn. So this one, okay. Okay, this one become a 3, this one become a 9, this one become a 6. Okay. These are the sum of the pair, right? And then we are going to find out the maximum number here. Okay. So maximum pair become a 9. 9 is assigned to here. Okay. Okay. How to write this code to replicate this functionality? Okay. The question is how to add these two numbers in order. Okay. Here's the trick. I think we already solved a similar problem. Imagine that what is the outcome looks like. The output matrix, that is 1, 2, 4, 5, 4, 2. Okay, because this value is placing the linear indexing order. Okay, and then then this one give you the summation of these two value, right? So vertical is the default direction. Come on. Okay. I mean, some students try to approach this problem using the loop statement. That's fine, okay? But I'm just giving you another way to solve this problem without using the loop statement, okay? Using the reshape function, you can reshape this vector to make this pair, and then just use the another built-in function of the sum. Then you get this vector right away. Then how to find out the maximum number? You can just simply use the max. Okay? Make sense? Okay, so here you're replicating this functionality. Map D is the reshape vector 1. What are the size of the vector 1? Vector 1 is the 1 by 100. That's why it's a 250, right? Okay. Then max sum D. Okay. Make sense? These are this one. Okay. Compare this code with my explanation here. Okay, good. What about, oh, sorry, that should be here. What about the E? E is the max different pair contain the maximum absolute difference of the pair. Okay, that's the similar, right? So reshape, we generate the reshape to 50. Okay, then how to find out the absolute difference of this pair? The mat differ is the absolute mat E first row minus mat E second row. Okay. That's the absolute difference. Okay, and then max differ pair is the max mat. Okay, by the way, this one is a not matrix, right? Factor. Okay, factor difference. Okay, does it make sense? Okay, so we don't need this one, right? We already compute the this 2 by 50 matrix over there, so we can use this one directly here. Okay. Once you reshape the vector 1 as a 2 by 50 matrix, you can easily perform this operation at D and E. Run it, no error. Run it, no error. Okay. Can copy this code, paste here. Submit. Okay, good.